Okay. Okay, guys. Here we go. Yeah. Hi, everyone. So this is Veera. So we are happily inviting you for today Kubernetes event. So maybe let me share my screen and then we will get into the session. Yeah. Okay. I hope my screen is also visible.
Yeah, yes, Vera, you can see.
Okay, guys. So the today agenda is we will learn about uh, the basics of Kubernetes, and then how it actually it works, what architecture it has, and what are the component it has, and then what are the key concepts we have to learn, like what is pods, what is deployments, what is services, and what are the other concept Kubernetes has. And then finally we will look into about how to deploy the entire full stack application in Kubernetes. In most of the part of this session I will try to keep it as a hands-on part. Okay, so then I hope it will make more engage, it will not boring for you. Okay, so before start the session, I want to know how many of you already have experience already working in Kubernetes. Anybody already started to learn, or are you already working on that? I hope Selvam, you are already working on it. Others? Okay, okay, cool. Okay. Okay. Anyways, this session is fully designed for newbies also. So even you are a beginner, so you can also understand. It's a very very simple tool. It's have very 10 to 15 concepts only it has. If you are clear about, you can nail the Kubernetes and everything. Okay. So let me introduce myself. So I'm Veera Solayapan. I'm currently working as a senior software developer at Tech System. I'm having 4+ years of experience in GIS, e-commerce, supply chain, and decentralized finance. So I'm also one of the co-organizer for Cloud Native Madurai. I'm other than I'm actively participating some conferences and meetups as a speaker. I'm also writing some blogs about full stack, blockchain, and cloud related services. I'm writing some articles. So this is about my small introduction. So let's directly get into the Kubernetes. Okay, so what is Kubernetes? It's to simply say it's help you to orchestrate, like manage your applications, your application containers. Like for example, you have many services in your application, in your organization. You have many applications. If you want to manage it, if you want to deploy it, if you want to scale your application in the futures, it Kubernetes is the best tool that will help you to do that. Okay, it has inbuilt features of auto scaling and load balancing features also it has. And then it has self healing. Self healing means if any problem it occurs, it can go to the previous state. It can um uh, solve the problem by itself. That features also it has by nature. And then it's almost suitable for microservices related architecture applications. Okay, and also most of the cloud platforms, they are supporting Kubernetes services also. They are supporting it. You can use it as a hybrid. You can connect, deploy your Kubernetes in your on premises, or you can use it in a cloud platform also. You can use it. It's very extensibility. So that means you can write your own plugins on the top of Kubernetes applications. Okay, that features also it's providing. Okay, this is about overall what is Kubernetes. It's, to simply says, it helps us to orchestrate, manage your application containers. That's it. Okay, so let's talk about how Kubernetes architecture is work. Okay, basically it has two components, two major part in their architecture. First one is uh, the control plane. Usually they are calling as a master node. Okay, and another one is worker node. Okay, so what are the components master node have? Master node have API server and scheduler and control manager and etc. Okay, what is API server is, it it is the responsible for all the API requesters, all the API functionalities, everything is managed by API server. So basically it will be the entry point of your Kubernetes clusters. Okay, so if you are giving any request, API server first will receive and it will react it. Okay, and what is scheduler? Scheduler is, it will manage, like it will schedule some particular process. For example, if you want to run particular application, right, if you want to deploy particular applications, scheduler will send the notification to particular worker node. Okay, it's a responsible for scheduler. Controller will maintain and check the current state of the clusters, as well as what is the desired state, what changes you have to do it. For example, in your clusters you are deploying 4 applications already is running. Okay, newly you give the fifth application you are going to deploy it. Controller will check the current state, and then what is the desired state. Okay, you want to deploy fifth application, right? Okay, I will do that. Controller will take the responsibility, and then it will do the scheduler, assign the process to scheduler. Okay, and then what is etcd? Okay, this is the distributed storage as a key value pair storage. Okay, it will maintain the state of your Kubernetes clusters. The, for example, what are the details it will store is, how many nodes it has, each nodes, what are the pods it's running, what each pods, what are the containers it's have. These kind of details, everything has been stored in this database etcd. So this database will maintain everything. So okay, so that's it for a master node. Okay, this is the components of master node. Let's talk about the worker node. What are the components in the worker node? Okay, so first one is kubelet. Kubelet is, it is the entry point of your worker node. For example, it will make the connection between your master node and then your worker node. For example, if you your master node send any send any notification, send any action calls, kubelet receive that, and then it will do the process. Okay, it will do some actions. Okay, so that is responsible for kubelet. And then what is Q proxy will maintain all the networking related stuffs. For example, you receiving particular time, you are receiving your application receiving a very huge network traffic. Okay, in that time you want to redirect your networking to another node. Q proxy take the responsibility, it will redirect your traffic to another node. Okay, for if already the load is the particular node have overloaded, the network will be redirected to another node. It's a responsible of Q proxy. Okay, and another one component, it has this container runtime. So uh, the worker node have capabilities of support multiple container runtime. One is Docker is one of the container runtime. And then you can use some other container runtime, so like a container d and some other types of containers, virtualization tools also, we it can support it. Okay, basically we can deploy the our container applications, we can deploy it. Okay, and then what is pod? Generally pod is the uh, basic unit of your clusters that will provide the environment for running your application. Generally how you are running, I hope you are already aware of how Docker is working, what are the component it has. If you are not sure, maybe previously we took the session for Docker session also. So we will share the link, you first watch that, then you will refer this Kubernetes session also. Okay, so it's very very simple. Container is your applications, like your Java applications, your Node.js application, your Python application, that is called Docker containers. That's actually running inside your containers. Okay, so your containers should be able to run it right in your clusters. So pod will provide the environment for your containers. Okay, so I think that's it. These are the components in your Kubernetes architecture have. Basically it has a two parts, one is control node, one is master node, another one is worker node. So for example, uh, if you give the request, how it will process. For example, if you are if you are giving the request for create the new deployment, for example, okay, so we can see kubectl, right? This is the one of the way we can interact with our Kubernetes clusters. So for example, via CLI, I'm giving the request to my clusters to deploy one particular application. First, my API server will receive the request. It will validate. It will check all the syntax, all the required parameters, everything is correct or not. It will validate. Then it will update the status to database. Okay, etcd database. So once the status is updated, control manager eventually it's frequently check the status changes. If any status changes is occurred, it will react. Control manager will react and then do the start the process, and then it will assign the task to scheduler. Okay, scheduler will responsible to find out best which node is correct node, which node is have the storage capabilities and everything. Scheduler will take care, and then it will assign the task to kubelet, the particular node kubelet. Kubelet will create the pod, assign the containers, assign the provide the environment. Kubelet will do that. Okay, if any network, any API calls, any access request is coming, proxy will process the traffic, and then if your current node workload is like enough, it can process. It will keep the network in the particular node. If it's not there, then if it's not able to do it, it will redirect the traffic to another node. So this is everything will be handled by proxy. Okay, so that's it. This is the overall architecture flow of Kubernetes. Okay, so now let's talk about what are the prerequisites. When we will check what are the key components it has, then we will come to these prerequisites. So okay, so the key concepts of Kubernetes is, okay, so the basic unit we discussed about parts, right? So we will do it in the demo part, how to create the parts. And then it has replica sets also. And then it has another concept of deployment. We will look into about what deployment, how to do the deployment. And then it has services, resources also it has. And then namespaces also we will look into about config maps, and then secrets and volumes, and then persistent volumes. What is the difference between volumes and persistent volumes? And then how to climb the particular persistent volumes, and then what is stateful sets, and then what is daemon sets. These are the major concepts. If you are clear about, then we can I think most of the use cases, Kubernetes related use cases, we can work on that. Okay, so these are the parts we will look into it about today. So what are the prerequisites we need in do your own hands-on in your system? You need a Docker setup. Okay, you can check the installation process via this link. I will share these links in the chat. I already documented everything. I will send the link also. So Docker setup you need, and then a kubectl. Kubectl is your CLI tool. Via terminal you can interact your Kubernetes clusters via executing some commands. You can deploy your applications and everything you can do it. Okay, kubectl is your CLI interface. Okay, and another one is minikube. Minikube is for a single node Kubernetes cluster. Basically we discussed about Kubernetes have two major nodes, right? One is master node, and then worker node, right? What minikube will do, it will have the single node. In the single node will have both master related components, and then your worker related components, everything will have it. Okay, so minikube is we are going to use it. It's for your development purpose. In production level, majorly they will go with some cloud services like AWS. They are providing EKS, Elastic Kubernetes Service. Azure, they are providing AKS, Azure Kubernetes Service. So that services, production level, some of the organization they are using. For the development purpose, we are using with the Minikube here. Okay, so these are the prerequisites we need. Other than we need a knowledge of Kubernetes, how Kubernetes is working. That's it. So maybe let's get into the demo part. Okay. So in the even hands-on part also, I have a two session. First one is basics, like what are the big key concept we have to learn, we are going to learn. And then advanced topic is how to deploy the full stack application, that we are going to look into about. So if you have any code editor, if you are using Visual Studio Code, I would suggest you to install Kubernetes extension that will help you to write your configurations files, the YAML files. Kubernetes. Okay, I am not sure about why it's not coming. Basically, it should come here. Kuber FX canceling. Okay, maybe some network issue or my Visual Studio Code issue. I'm not sure about. So usually you can see this icon once you install. It should come in the marketplace. So you can see it once you install. You can see the icon here. Okay. So what will help? It will give some prompts to deploy your write your manifest configuration. Everything it will help you. Okay. So first topic we are going to look into about pods, right? So let's create. Okay. Let's check how to create the pods. Pods.yaml. Okay. So one thing I forgot to tell you. Okay. So the prerequisites we checked that, right? So to confirm it, let's check Docker version. Okay, Docker version is installed, and then Minikube version. Okay, Minikube is also installed. It will help you to verify whether it's properly installed or not. And then kubectl version. Yeah, kubectl also installed in my system. So that's it. So to start your cluster, you have to run. I already run my cluster here. So this is the command minikube start. Okay, this will start your Kubernetes cluster. To verify it, you can just run kubectl get pods. There is no pods. For check the nodes, kubectl get nodes. This is what I told you. This is a single node cluster, right? So only one node we can see it. Okay, so this is a major node. It's work like a major node as well as the worker node. So that's it. I think all the prerequisites we have. So let's get into the pod. So okay, let's create a single pod to deploy any kind of images. Okay, so let's type pod. Okay, so what is the benefits of using this Kubernetes extension is this one. So I don't want to remember all the configurations, so it will help you to write your manifest files and everything. Okay, so I can just change my image name nginx. Okay, I have to mention how much resources is going to utilize, memory and CPU, and then my port. Okay, this is the default running port is 80. It's like 8000. So this is my pod configuration. I have to mention my API version and then what type of resource it is, the pod resource. Okay, so it will download contain an nginx image. It will create the container for that. The container will deploy it to the. So this is the container configurations. The image is a nginx image, and then how much storage it's utilizing it, and then port. Everything I'm configured here. So pod resource will create the pod, and then it will install into the or the our node. Okay, so I mention my pod name. Okay, and then my labels also. Generally labels will help you to group to identify your services. For example, in your application you have a backend system and front end system. If you mention in your backend system various services you have, okay, like Python application, the Java application, if you have everything, you can consider everything as a backend. So you can mention it in the label. You can label, you can mention it's the backend. So if you want to execute particular actions under the label under the backend label parts, just selecting the labels you can do it. Okay, so now let's deploy the pod. Basic how to deploy the pod. Kubectl apply -f pods. Okay, so before apply the command, let's open another terminal to watch what's happening. Kubectl get pods details, and then I want live watch command. Okay, so now let's execute the pod. Okay, so my pod is created. In right side you can see, okay, its container is also started to create. Okay, so -v is you can watch the live the process of the particular actions or process, everything we can consider. Okay, so now my pod is running successfully. So this is as simple to create the pod. Okay, so my pod is running in my clusters now. Okay, so that's it about the pod. So now let's talk about the replica set. What is replica set? Generally, if you want to create additional system for your recovery purpose, for your any some risk management purpose, risk management purpose, so you want to replicate your existing application, you have to deploy your same application in other system also, right? If any problem it occurs, you have to maintain your application in a stable. Okay, so that purpose replica sets we are using it. So it will copy and then create the clone of your applications. So replica sets dot yaml. So I will just delete it previous on kubectl apply, sorry, delete if what YAML. Okay, so my pods also deleted. So now let's see. Okay, no pods is running. So now we will create the replica set. So let's type replica controller. So extension will give the entire code for you. Okay, so it's almost similar to your pod configuration. You just mention how many replicas you want. Okay, so that is the only difference here. I want three replicas, three copies of my particular application. So if first application goes down, first container pod goes down, rest of the containers will exist to receive the request and do the process. Okay, image is in nginx. Okay, and then port is 80. So now let's deploy this one. Kubectl apply -f replica set. Okay, here you can see three containers are creating it. That means three parts are actually creating, running simultaneously, even using the same image. Okay, so basically it will distribute the network traffic also. So first one will receive 33% of the network, second 33, third 33. This is how the Kubernetes algorithm it has. It distributes the networks. So yeah, all my three parts are running. So this is the replica sets. It will help you to copy your applications to maintain application stable for a long time. Okay, so this is one thing. Let's delete that. Let's move next one. Okay, so that's it for a replica set. What is next one? Next one is deployment. Okay, so let's talk about what is deployment now. In your application deployment, you have to apply some different kind of strategies. Like in future you are going to upgrade any versions, you can't stop your current service, and then your application should not go into the downtime, right? So in that case you want to apply some strategies, in your deployment resource, that will have some functionalities to give some deployment strategies like a rollback strategy, recreate strategy, these kind of things. Your deployment resource will help you. Okay, let's see how to create the deployment. Deployment.yml. So let's type deployment. Okay, so your extension will give you, so it's almost similar for your pod configurations, your replicas configurations. What is the difference is the resource here. Okay, resource is the deployment, so it will have the strategies, it has the inbuilt functionalities of uh, you can make your own deployment life cycle. Like I want to shut down previous, I don't want to shut down the previous applications, I newly upgrade the new services. Your deployment will help you. So for example, you already deployed 3 parts. Okay, you are again you are going to deploy another new version of parts. Okay, so deployment will check, will delete one by one. If any issues occurs, it will roll back to the previous version. So this kind of functionalities it has. So I mention my nginx here. My port is 80. So now let's kubectl apply -f deployment. Okay, okay, so my nginx application also started to run. Okay, so I have one question now. I deployed my applications in my clusters, how others can use it? Okay, so that is the problem right here. So it's running inside your containers. How we can expose, how we can make our application to public, others can use it? So in that case, services we have to use it. So services will help you to expose your application to public access, public internet. Okay, so basically service have 3 categories, 3 kind of types it has. So we will talk about one by one. First one is node port dot service dot yml. Okay, so let's service, create the service. So I'm creating the service, I'm making the service for my nginx deployment, my app deployment. Okay, so here I mentioned my service name, my app service. Okay, and then I'm which deployment I'm going to map this service. So I'm using the selector, and app is my app deployment. So I mention my app here. If some other names you mention, you have to add it here. Okay, so my container port is 80. Which port I'm going to target, which port I'm going to expose it? I'm going to expose it for 7000. Okay, so what is my service type? Node type is node port. Use basically node port will what it will do, it will use your container will create the specific port for you. Okay, and then we can use the cluster IP address. Okay, you can use the cluster IP address to access our application. Okay, so let's see, let's deploy the service and let's see that. So my deployment already done. Now let's deploy the service dot, okay, sorry, node port. Okay, node port is also created. I will, no, the same terminal. Let's see, get what are the services deployed, svc. Here you can see my app service, type is node port, cluster IP address this one. Okay, this is my pod running, and then my port, it's the 8000. Sorry, this is my container uh, assigning port. Okay, maybe this is the wrong one. I have to use 80 here, not 7000. So what's the target port and what is the internal port? Both are 80. Let me redeploy it. Yeah, configured successfully. Let's see. Yeah, same. So I have to use cluster IP address instead of cluster IP address. Generally cluster IP address, it's a private one, you cannot access it. You have to for node port, for the majorly node 4 is using for your testing and development purpose. I'm going to convert it into my local host. How I will do that? Kubectl, I will do port forwarding. So my service, my app, my output port is 7000, external port is 7000, internal port is 80. Okay, so now I believe I can access my application in 7000. Okay, so now I can see my nginx container in localhost 7000 port. Okay, so this is how you have to expose your application using node port type. So now let's talk about another one service, is a load balancer. Okay, so load balancer, let's create the new file, load.service.yml. This is also almost same service. Okay, I have port is 80. So it will assign external address, external public IP address. You will get that. Okay, so 80, and then type, type load balancer. Okay, so previously this for using node port, you cannot see external IP addresses. You can see external IP address none, right? If you are using load balancer, it will assign the public address for you. Through that you can access your service. So let's deploy this one, or I think I have to stop the previous one, previous service. Delete. Okay, previous service is deployed. Now deploy the kubectl apply load balance load service. Okay, so my load service is created. So basically you need a load balancer here. So minikube itself, it has a load balancer service also, that we will start it. So let's see, kubectl get svc hyphen watch. So the load balancer status is bending because my load balancer is not started yet. So for that, in minikube they are providing inbuilt load balancer. Let's start that, which is called minikube tunnel. Okay, 26. Okay, so now you can see the public IP address here. Okay, we have to use this IP address to access your nginx server now. Oh my god, yeah, take it, close this one. My port is 80. Yeah, that's it. Now using your public IP address, you can access your nginx server here. So this is how the load balancer will help you to expose your application. Okay, so that's it about load balancer type. And a service, another kind of service also it has, that is ingress service. Basically instead of IP address, we have to assign some domain name, right? Okay, so ingress will help you to assign the particular domain to your pod, and then in your node it will help you to, even you can assign some subdomain also, you can assign it. Like let's for that we need a domain. I don't ingress service.yml. I will just walk through you how to create the ingress and how it look like. So your extension, if you type ingress, it will help you. Okay. So your host, you have to mention like a host, which domain you have to mention the path. If particular path it's hit, which service you are going to access, and then what port it has. So if for example you have some other path also, if you have like some other services also you are running, you can mention it like this is like a API, this is log, so you can mention log service here, you can mention your API service here. Okay, this is how ingress will help you to assign domain names and then redirect your particular request to particular service. Okay, so this is about ingress. Maybe let's avoid the error, let's add some dummy port. Okay, so that's all about majorly load balancer and ingress. They are most of the times it's using it for production level. Okay, or staging and production. Load balancer and ingress, they are using it. Node ports is only for your development and testing purpose. Okay, because you need a load balancer and domain name, everything you need. So load balancer you can just redirect to your local host, you can test it. So I think that's it for services. I hope you learn about how to expose service to outside. Now let's talk about what is namespace. Okay, so generally Kubernetes, it has default namespace. What is namespace generally? So in your organization you may have a lots of services. For example, let's talk about my current project. I'm working in a data pipelines. In here, we are using almost 50 services. We are using it. 10 services for ingestion process, 10 services for processing the data, 10 services for validating, 10 services for monitoring. So we can see we have to group the services under the particular name, right? Particular category. So in that place, namespace come into the picture. So Kubernetes itself, it has get parts. So basically if you don't mention any namespace, it will deploy your application in a default namespace. So for that you can, maybe I will stop this one, kubectl delete -f load balancer kubectl deployment. Okay, so let's create the new namespace and then we'll deploy our application under that name, specific namespace. So terminating name space.yml. Okay, namespace prompt is not coming. Like I have some samples, I can directly add it here. Okay, so what is the major changes? This one, the kind, the resource kind, what we have to mention. Our the namespace resource we have to mention. We have to mention my namespace name. I will mention cncf mdu. Okay, in the same YAML file, I added another configuration for my deployment. Okay, so here I have to mention my namespace cncf. So the particular deployment will happen under the cncf namespace. Okay, so my image is nginx port is 80. Okay, here we go. kubectl apply namespace YAML. So my CNCF namespace is created. My application is also deployed um, under CNCF names. Let's check that whether it's deployed or not. So what is the command we have to give for get all the parts? kubectl get parts, right? It will return error because I am deployed my application in CNCF namespace. So if it will directly check the default namespace, is default namespace no parts is there. So what I have to do, I have to mention my namespace here CNCF MDU. So under the CNCF namespace, I can see my pod is running. Okay, this is how we can group our services, our resources, and everything, our parts and everything. We can group it. So your application of let's talk about any enterprise application. It's not only have a single service. Majorly, it will have around 30-40 services it should run. So we can group it particular services for a monitoring purpose, particular services are for a logging purpose, particular services for you running backend services. So this is how we can group it. If you want to apply in a particular actions, you can apply the particular steps to the particular namespace. So this is how namespace will help you to group your resources. So let's delete that. Delete. Okay, I hope it's deleting. Yeah, now let's talk about another. What is next? Next is config map. Okay, config map is nothing like a majorly in your application you have to maintain some environmental variables, right? Okay, so that will help you to, you have to pass your applications. So config maps will help you to uh, assign some global configuration details. You can use the global configurations to multiple resources. For example, config.yml. So I mentioned config YAML. Okay, this is the YAML script for config map. Kind is resource name is config map. So name is my app. So my key value the environmental variables are username, CNCF Madurai, URL http cncf mdu.com. Okay, this is my, this is how I have to configure my environmental variables. Okay, what is the advantages here is you can use this same configurations, you can for multiple parts, multiple resources, you can use it. Okay, so let's talk about the deployment. I'm creating it. So my image is nginx. What is 80? How can I attach my configuration to particular pod and deployment? So how can I use it? Like these are the environmental variables, right? So I mention environmentals from, I'm using config map ref name, what config map I'm going to attach. I'm going to attach my app. Okay, so your pod will go and check my app configuration maps, and then it will try to use these environmentals. So this is how you have to attach your configurations files to uh, multiple resources. You can assign the same configurations. If you want assign another deployment also, you can use it. Otherwise, this is that you in the same pod itself you can mention environmental variables, but it's only specifically for the particular country, a particular pod, particular containers. If you are using config maps, you can assign it for multiple resources. Okay, that is the advantages here. Okay, so next part is we have to check another one is secrets. So in your application you have to maintain some confidential details like a password, everything you have to mention, keep it right. So your secret service will help you to keep that. Like let's talk about secrets.yml. Okay, so where prompt will help you to that, and then you can assign the password. Basically you have to assign encoded kind of password, you have to give it here, like the base 64 password, you have encrypted value, you have to keep it here. Like opac is a type of encryption decryption mechanism Kubernetes is using. It will decrypt your password and then it will use it your particular container, particular pod. Okay, so like how to create the secret, let's see. Wait, so for example my password is cncf. Okay, I'm going to encrypt it now. cncf cncf madurai. Okay, base 64. So this is my encrypted kind of password. I got it. I have to give it to my secret here. Okay, so basically what it will do, it will decrypt it. Okay, so I have to give this one, this value I have to give. Okay, so this is the decrypted value. So this is how it will go up. Will decrypt it and then it will assign the value to particular your applications. So let's attach my particular secrets to my particular pod. It's also similar to your config map, how you are attaching your config map. Here you attached via environmental from this tag, right? So see, something similar here also you have to use deployment, my nginx image for a like a demo purpose. I'm using nginx. In your production or in your application you have to use your specific images. So here I 80 port, and then how can I attach my secret here? So this is also same but slight similar, slight different I think. Just a second. Env, not env from, I'm directly using no environment name. My environment name is password, sorry, name I have to mention password. Okay, and then where I'm going to get the value from secret key ref. Okay, name is, what is my secret name? My secret. Okay, that I have to mention what is the key I'm going to use it. Key is password. This is how we have to attach your passwords, secrets to your containers, your parts. Okay, that's about your secret service. Let's talk about volume. Okay, so basically deployment is the stateless stateless service. So it will not maintain any state of your application, any data of your applications. If you want to maintain any data persistence, you have to attach the volumes. Okay, so volumes means your particular data will be stored in any particular file of your clusters containers. So let's look into it, how we have to create the volume, how we have to attach it into the particular pod. So let's create the new file, volume.yml, create the deployment. Okay, port is 80, name is as we know nginx. So I'm going to attach the volume here. Let's see how to create it. So I have to mention my volume name, volumes. Okay, name of my volume, data volume. Okay, this is my volume name. Like it will be empty directory. Okay, I'm going to attach it with my pod. How I can do that? I have to mount that. So volume mount key I have to use. Name. What is the volume name? Data volume. What is the mount path where my particular container data is going to store? Slash data. Okay, this is the path I'm expecting my container data should be stored. So this is how you have to mount your particular volume to your particular deployment, particular container. Okay, so now not next is persistent volumes. Okay, so what is persistent volumes? What is the difference between volumes and then persistent volumes? Okay, so it's almost similar, the difference between environmental variables and config maps. Environmental variables only previously we checked that environmental variables only for the specific deployment, right? Specific containers. If you are using config maps, you can assign it to for the multiple resources, you can assign it. Okay, same thing. Volume is only for your particular deployment, particular container pod. If you are using persistent volumes, you can assign same uh, storage place to multiple pods. So it's a kind of global storage. Many resources go and store the data and get the data. So let's create the file persistent.yml. Okay, so let's talk about how to create the persistent volumes, how to climb the particular storage to the particular deployment. So here in extension will help you to write your config file. Okay, so it's writing some additional things. I don't want that. It's like a nfs means remote files storage service something. So in the particular server for your volumes, everything will be stored in third party servers, some other servers. Okay, I don't want that. This configuration, I just need to store my data in file cluster file itself. So I will remove some of the configurations here. So my persistent. Okay, okay, so this is my persistent volumes. I want how many data I am going to give it. I'm going to give it 10 gp. I'm going to allocate 10 gp data. Okay, access mode is read, right? Volume mode is file system. Persistent volumes, I don't want recycle approach, a retain approach. So if you want to know what are the parameters, each parameters is what it's doing it. Yeah, actually persistent volume is actually one of the major topic. It has various steps and categories. If you want to get into more, you I would suggest go and directly check their officials documentation. So here you can see what are the various types of volumes it's supporting. So there must be a table. Yeah, this one. Okay, I missed that. Yeah, so these are the various types of volumes it's supporting. So I just need a host path to store the data in my cluster container itself. If you want to store some other third party service like Azure file system, nfs something, you can refer this documentation and you can implement for your project. Okay, so I just want my host path. I am going to configure it. persistent volumes claim strategies retain, and then I'm using standard approach, and then my mount path is not needed, and the NFS is not needed. I will remove it. I'm going to use my host path. Typo. So path should be slash path some data. This is the place I want to my store my data. Okay, so it's globally all that. Yeah, I'm allocating 10 GB storage for my clusters global storage. So I'm going to give the request to utilize particular storage, like some amount of storage I'm going to allocate for my pod. So how I can do that? I have to use volume claim. I have to use it. Okay, so in volume claim, it's almost similar. I have to mention how much storage I need. I just need 1 GB. Okay, and then I have to mention my volume name. So what is my volume name? Persistent volume, my VP, right? So this is my volume claim is my VPC, my VP. I have to attach. So I'm going to give the request for 1 GB to my VP persistent volume. So now I'm going to attach this claim to my pod. How I can do that? Deployment. Okay, so 80 port nginx. So I have to attach this volume claim to my particular pod. So previously we talk about volumes, right? Same thing, we are going to use it, but we are instead of mention empty directory, we will mention persistent volume claim here. So my storage data persistent volume claim. What is my claim name? What is my VPC, right? This is my volume claim name, and then I have to mount the particular volume to my particular container. So it's also similar like what we did for volumes mount, volume mounts, name, storage data, and then mount path data API something. Okay, so this is how I have to attach my persistent volume to my particular container. Okay, so that's it about persistent volumes and then persistent volumes claims. These two topics, right? These things, we will another section also we have, right? Full stack application deployment. In that part we will look into it. The demo part we will look into it. I will execute it. So and the remaining part is stateful set and then dimension. Let's talk about what is stateful set. So for in some of your application requires some stable environment, right? It's not go down at any time at any cost. So in that kind of critical systems, you want to provide some stable environment. So stateful set will help you to uh, provide the service. It has inbuilt persistent volumes service. You don't want to mention volumes in X additionally. So let's talk about, just check that stateful state.yml. So this is my stateful set configurations. I have to mention my service name here. What service I'm going to use it? My app. This is also similar to your deployments. What is the advantages is Kubernetes provides some additional functionalities for stateful state. should not go down your applications. It's a like a it's specifically for stateful applications, like you are going to deploy your database should highly reliable, right? It should not go down at any time. So then in that kind of case you can use stateful state. So it has volume persistent volumes by itself. So it will allocate the storage. You don't want to mention persistent clients and everything, you don't want to mention it inbuilt, it has that. So you can assign particular volumes to your particular container, and then particular pod you can assign it. This is how you have to create your persistent volumes. It's almost similar, like how you most of the configurations are similar to your deployment manifest. So I mentioned the image and then container and the mount path. Okay, here the volume claim time, this is only different, but it will help you to give the persistent volume storage. Okay, so this is how we have to create the stateful state. Basically it's provide the unique identity. Kubernetes, it will take care of this stateful state should not go down. Okay, so it will provide some additional taking care of that. Okay, so what is next one is daemon set. Okay, let's talk about what is daemon set. So basically it's daemon set is running systems behind the process. Like you can't you majorly it is using for reduce your manual process. For example, you already have two nodes, okay, in your clusters. Apart other than master node, you two worker nodes you are running it. Okay, you in two particular nodes you want to collect some logs, and you have to send it to some Grafana and Prometheus services. Okay, so how additionally if you want to add other 3 4 5 nodes, you are going to add it. How you will do that? Initially you have a two nodes, you deployed this particular service, log collecting log agent service. Okay, it will start to collect that, and then another in eventually you are going to add a fourth fifth node, you are going to add it. You have to manually assign the deploy the log collector, right? Third another nodes also you have to deploy it. To avoid the manual process, daemon sets will help you to automate that. So if you deploy your service as a daemon set, just a second, let's create daemon sets. Just a second, I think there is some typo name. D-A-E, I think D-A-E, daemon set dot yml. Okay, I think daemon set. Okay, no have a configurations, it not giving example. I will have some examples, I will let. This is also similar to your deployment configurations. Only changes this one, the kind, the resource kind, daemon set. So basically if you are configure your service as a daemon set, it will run the process in the behind. If you add additionally some other nodes, daemon set also will automatically deploy it into your upcoming nodes also. Initially you have a two nodes, you deploy your daemon set. If you are adding fourth third node, your daemon set should automatically deploy it into the third node. Okay, that is the one advantages of daemon set here. So you don't want to deploy any service in a manual way if you are defining as a daemon set. So that's it. These are the things. I hope we covered most of the major basics. Okay, so now let's get into the how to deploy the full stack applications. Okay, if as of now you have any doubts, you can ask. Okay, okay, fine. So let's create the deployment for my full stack application. In my full stack application I have a three parts. First one is front end, second one is back end, and another one is database. So we have to create the deployment for all three, and then services also we have to create for all three services. Okay, so let's create it for my front end services deployment. front end deployment. So application name is, label is also front end. My image, I'm going to deploy my own application image. So I will tell you, in the previous session I created, I deployed the full stack application using Docker. So I pushed the image in Docker Hub. So we are going to use the image in our Kubernetes session. So we can see web app and then go API, right? So in web app, let's use the latest one, v 1.0.1. So we will use this one. Okay, and then my port is, it's running in 3000 port. Okay, my container port is 3000. Okay, I'm going to give the space. CPU is 1 CPU, not 500 MB, it's not enough. And then storage 1 GB storage. Sorry, it should be string. So that's it more for my front end deployment. And then let's create backend deployment. Sorry, deployment, backend deployment. So application name is backend, container name is, label is backend, container name is also backend. Image, I'm going to use my Golang application image. Port, it should run 8000. Okay. In the repository I can see Golang. Okay, so I'm going to give this space for a almost same 1 GP, 1 core, sorry, memory 8000. I have to pass some environmental variables to my front end, how my front end will communicate with backend. So that backend API, I have to mention it, right? So in the front end, I will mention, I already have it, so I will just replace it here. Okay, so this is my backend API URL. So backend is running localhost 8000, right? So it will try to communicate with the backend system. So here in my backend system also have some environmental variables to communicate with my MongoDB server. Okay, my DB server. So that environmental variables, I will just replace it, which is Mongo URI. So it should run Mongo service port. Okay, so now my third deployment is Mongo deployment. Okay, I'm going to mention Mongo deployment. Says Mongo images. I'm going to use some public images. I have public repository images. So public ECR using 4.4 Bionic version, Mongo version. I'm going to give the storage for less storage. I'm going to give 512 MI and then 0.5 GB CPU for my It's just a testing purpose, right? So this is enough. 27017, that is the port of Mongo is running. So here I have to configure my persistent volumes and everything. Okay, so for that I'm going to my add persistent volume details. So this is my Mongo PV. Okay, size is I'm allocating 5 GB totally to my clusters. File system, read write, and retain standard mount path, host path is data slash Mongo. So this is my persistent volume host path, and then I'm going to give persistent volume claim. I'm going to claim some storage. So persistent volume claim. The request to storage is, this is my, what will be the name? Mongo PVC. Okay. Storages. I'm using exact 5 GB storage. I'm going to assign, and then storage class is standard. I think that I don't want to mention. Read write file system. Okay, what is remaining? Volume name. Volume name. Mongo persistent volume. That volume I'm going to maintain. So I have to attach it with my Mongo deployment. Volumes name Mongo data persistent volume claim. Okay, claim name is Mongo PVC. Okay, this is my claim name. I have to mount it. Volume mounts Mongo data, and then mount path data slash db. So that's it. We created our deployment part now. Next one is our service. So we have to create 3 services. Services.yaml. This is my deployment.yaml. Service. 3 services I have to create it. Service 1 backend service. What is the label I mentioned? Backend, right? Port is 8000. 8000 is running. Type, I'm going to use load balancer. Same approach we have to do it for other services also. So it's a front end service. It's a front end. 3000 it's running. And then this is the Mongo service. Load balancer and port is 27017. Okay, that's it. Let's deploy and check the application now. Okay, I hope nothing is running. kubectl get pods. No, nothing is running. Let's see. kubectl get pods. Let's see in the live changes. kubectl apply -f deploy. Oh, sorry. I have to switch the directory and check that. Delete cd advanced kubectl apply -f deployments. Okay, let's stop this. Okay, and start. Here we go. So it started to create it. Deployment. Let's deploy the service also. Service is also, I think, deploying it one by one. Let's see. Yeah, service is also deployed. My I'm using load balancer right here. You can see all the services, 3 services are running. So let's see. My pod is also running, I believe. It's getting error, but it should start. Yeah, backend is started. So now let's kubectl get svc. So my front and back end everything is running. So I'm even it's running load balancer. I'm going to redirect it to my local host. So I have some reference commands. So I'm just executing it. My front end is see. Let's check why backend is failing. kubectl get pods. Backend is crash loop backups. kubectl describe to check what's happening in the pods. Okay, MongoDB is bending, so that's why. Maybe once MongoDB started to run, it should run. kubectl get pods -watch. I hope it should start. Front end is running, back end it goes error. MongoDB still bending. Maybe it may take time to start it, but it will be actually. Is there anything configured wrongly? I think. Okay, this one DB, this one B is missing, volume mount. Backend started to run. Space is there. This is correct. Standard. So some typo is there. Standard storage. me retain Mongo. Okay. Persistent. Okay. Now let's redeploy it again. Maybe MongoDB is not started properly. So now it should start. kubectl get pods. Still MongoDB is pending. Let's see. kubectl get describe pods. Not found. Could not found the persistent volume claims. Unbound immediate persistent or promotions node available. No permissions victims found for incoming pod. So maybe it's creating the pod issue. Let's see. Read write once PVC volume binding getting VPC could not find V1 persistent volume claim name volume data. I hope everything is
Vira, can you check PVC status? Keeps it at PVC.
yeah. kubectl get PVC. Yeah, it's there. Okay, this is also bending. PVC is bending.
Yeah, first one is pending ratio. That's the reason it's not assigned to it.
Yeah,
Describe PVC. Let's see what is the issue.
kubectl get describe PVC Mongo PVC cannot bind the requested volume. Storage class name doesn't match. Okay, maybe I have to mention storage class name. Okay, got it.
Yeah. That's the reason.
Storage class name I missed to add it. Storage class name standard, right? Standard. Yeah. I hope now it should run. Let's redeploy it. Yeah. Now it's
Yeah,
bounded.
now it's found.
Bounded. Cool. kubectl get parts hyphen watch Mongo running. Okay, maybe it's will try to restart it. I believe. Let's stop. Check that. MongoDB is running. My backend should run now. Let's see. Okay, now let's describe the backend. kubectl describe parts. back of restarting. It's trying to restart the application. Failed container backend in backend deployment. Back of what is the problem here in my backend application? I think backend is correct. Environmental is correct. Container name. Backend correct. Replicas is correct. 1 GB is resource is correct. Environmental is correct. Name is correct. Container 8000 is correct. URI MongoDB. Okay, everything looks good. Maybe let's try to restart that. Let's see. kubectl get parts typo. Okay, again it's crash lookup. What is the major changes? I don't see any changes here. Let's kubectl logs. My mm, I think Mongo service having some issue. Mongo services is running. It looks services are running. Mongo service. Yeah. kubectl get svc. Yes, Mongo service is running as expected. 27017. Correct. Unknown service. Mongo service. Dial up. Close save. So deployment. So Mongo service I have to mention. Yeah, correct. Mongo service. Okay, typo. Service. Is the name correct? No, right? Yeah, this is the problem. I mention serve vi vi vi. Okay, so this is the problem. Let's redeploy it. Service YAML. Okay, so is configured correct. Now let's see. Cube get parts -w. It should start. Let's see. Crash lookup back of Mongo service. kubectl get svc. Okay, I will delete that. Maybe it's because of the port. Kubectl delete -f service.yaml. Okay, kubectl delete get svc. Again, the wrong configured name is keep on running. So maybe it's referring that name. So maybe that is the issue. Or I will just revise it and then delete that also. Kubectl delete -f service. Yeah. So now we will correct that. Service, service, service. Okay. Now let's deploy it. Okay. Now it's configured in a correct name. Let's see why this is not starting it. Kubectl get parts. Again kubectl uh, get parts hyphen v. Okay, let me redeploy it. Cubes, kubectl get apply hyphen f deployment. Mongo configured kubectl. What changes is there? Kubectl delete deployment. Everything is looks correct, like a deployment app, Mongo URI, Mongo service. Yeah, everything is correct. Okay, let's see this time. Kubectl get svc. Okay, here we go. All three are running. Now I will just do the port forwarding. So my backend, I'm going to make it for localhost. Okay, and then my front end, I'm going to make it for a 3000 port. Okay, so now let's start. Check localhost 3000. Handling resources, handling connection 3000. Okay, maybe it may take some time. So all three services are running as expected. So let's wait. Yeah, so this is our application, sample application. So I can add a member, selvam at gmail.com, Madurai. Okay, cool. So test at gmail.com, Chennai. So now our application is running in Kubernetes, via Kubernetes. That's it, guys. So yeah, if you have very soon local host is stopped because maybe it's because of the storage, I think. Yeah, I think that's it. So we are done the session now. Yeah, if you have any queries, you can feel free to ask. Okay, okay, only we have a yeah, Selvam and me. Yeah, that's it, guys. So maybe stop the recording.